Ladies and gentlemen, welcome back. Today we're going to be talking about adding and subtracting polynomials. Now, if you remember, polynomials just represent a specific situation. Or if you really want to break it down, a polynomial just represents a number. So what I mean by that is, when you decide what to plug in to this polynomial, what you decide to plug in for z, and you simplify, you're just going to end up with a number. Okay? So since that's the case, polynomials can be added and subtracted in the same way that we add and subtract monomials, or in the same way that we add and subtract regular numbers. Okay? So the only thing we have to note here is when we have to find the sum of two polynomials, you guys have already combined like terms for much of the year. All we're doing is combining our like terms. So if you will, since this is finding the sum, we're going to add these two polynomials. 1z squared plus 2z squared is just 3z squared. You may not combine your z squared terms with your just z to the first power terms. Okay? So only combine your z squareds. Now, plus 5z, and we don't have any other z to the first powers. So we just bring that down here. And lastly, we have a positive 4 and a negative 5. So 4 plus negative 5 results in negative 1. So here we are. You've found the sum, and you cannot simplify that any further because we have no more like terms. Let's try another one. Same idea. Let's find our like terms. 2x squared. Then you got to note this plus sign in the middle. 1x squared. So there we go. 3x squared. 3x. It's a positive 3x. Over here I've got a positive 1x. So 3x plus 1x is a positive 4x. And then I have a negative 1 plus a negative 3. And I'm left with negative 4. So here we are, completely simplified. Now, the only thing that changes when we need to simplify the difference of two polynomials is that you need to note that this second polynomial, yes, it represents a number. What that means is that this whole thing is representing one number, which means when you subtract with this subtraction sign in the middle, you've got to distribute this subtraction sign to each of the three terms. So what do I mean by that? Let's find our like terms again. 10z squared minus 1z squared. So that's 9z squared. Now you have 6z. We've got a minus sign, so 6z minus negative 8z. This is the only tricky part, folks. 6z minus a negative 8z is 6z plus 8z, which happens to be positive 14z. Remember, you gotta do bam bam when we have minus a negative. Lastly, you have the number 5. It's a positive 5 minus positive 7. So 5 minus 7 is negative 2, and there you have it. If you're afraid that what I just did here, if you're going to forget about that negative sign in the middle, that you have to give it to all three of these, we can rewrite this situation in the same way in which we used the elimination method when we solved systems of equations. And if you like writing it this way, and we are subtracting, so you put your subtraction sign out front, it might make it easier for some of us. 10z squared minus z squared is 9z squared. 6z minus a negative 8z is still plus 14z. And 5 minus a positive 7 is minus 2. All right, let's jump on down to our last example here, number 4. Please write the perimeter of the figure as a polynomial, then simplify. So the first question we must ask ourselves is, how do you find the perimeter of a shape. We all know that if we just add up all four sides, that'll give us our perimeter. Okay? We do have variables though, so this is a little different than what we've seen before. But you should acknowledge that since this is a parallelogram, this side and this side should be the same length, and this side should be the same length. What does that mean? That means I've got 4a plus 3 over here. That's the distance from here to here. And this is going to be 2a squared minus 1, just like the other side. Now, we could add all those up, and you'll have something that looks like this. You have to do a bunch of addition. Or we can write an expression, 4a plus 3, but since there are two sides, we can multiply by 2. And then we can add 2 times the quantity, 2a squared, minus 1. This is the same, it's almost like a formula for finding the perimeter, is you do 2 times one side plus 2 times another side, or 2 times the length plus 2 times the width, and that'll give us our perimeter. So when we distribute, we should have 8a plus 6, because you got to give that 2 to everything there, plus, break down your plus sign, 2 times 2a squared is just 4a squared. And guess what? It's a positive 2, but it's a negative 1, so you got to say minus 2. Now we need to simplify this polynomial, so let's combine all of our like terms. And usually we put our answer in order of, we call it descending order, which means I've got a positive 4a squared, a positive 8a, and then I have positive 6 minus 2, which results in a positive 4. Descending order just refers to the variables, okay? And we usually put the largest exponent first, the next largest exponent second, all the way down to the terms that do not have exponents. So right here, you have written the perimeter of this figure as simply as possible, okay? And once we're given a value for a, we can simply plug it in, and we'll have our perimeter, okay? And since there are no units, you don't have to label the units here. Let's jump down to our summary real quick. Just please remember that when you add and subtract these polynomials, all we're doing is combining like terms. Piece of cake. And lastly, also remember that these polynomials, they just represent numbers. That's why we can add, subtract, multiply, divide, okay? Just like we're dealing with regular numbers. All right, the assignment for tomorrow is going to be what's at the bottom of your paper. I'm not suggesting you start it, but it's there so that we all know what it's going to be. And if you wanted to get a head start, you could. All right, folks, I'll see you tomorrow.